Welcome back to ATAR examination preparation online course. Just go through question 17 for QCAA external assessment 2022, paper 2, question 17. So this question is complex, unfamiliar, and also using technology. So I'm going to show you how to solve this question. So we have the condition is we got the snail travels straight line in that direction, so which is from here, straight line. There's an ant follow after the snail, travel the same direction. But after 12 minutes, so means the ant is 12 minutes behind snail. And then they travel together, and then they travel the same path and move this on the acceleration. There's a condition called acceleration of 2 centimeters per square minute. So that's another condition. So we need to find out. So they meet. So those two animals, they travel the same direction. So ant eventually catch up snail at 15 minutes time. So what that means, so we give the velocity. So velocity is the snail are using for equation 1. So the velocity of a snail, we call Vs. T is given 1.5 log 1 plus t squared. Now, eventually, when they travel together, they eventually will be equal when they meet at time when 15 minutes. However, the interval travel, the answer is from 12 minutes, so t is for Vx, so x representing displacement, so travel the distance of the two animals. So the ant is travel from 12 to 15 minutes, that's the total displacement. But ant travels a little bit longer because it's slow, or snail slower, travel from 0 to 15 minutes. So eventually they catch up at 15 minutes time. So we need to determine the velocity of the ant at point A. So which is point A means these are 12 minutes. So t is 12. So we need to find a VA, velocity of the ant, at time is 12. So I'm going to use I'm going to use velocity equal to acceleration, integration of acceleration. So this is the formula we talk about. Equal to, that's the ant. Velocity of ant equal to integration of 2 dt with respect to time. So the answer is 2t plus c. So now we're going to decide what the c is. So this we need to determine. So how do we do that? So we need to use velocity of the velocity of snail. We already know is velocity of snail is given this equation 1. So we're going to integrate it for the displacement for the snail. So the displacement for the snail is from 12 minutes sorry, my apologies. So this is still ant. So displacement. So we got a velocity. So the displacement for the ant is from 12 to 15. So we integrate it. So that's the unresolved. So what I'll do is I can we can leave as equation 1. So I'll go to the equation 1. We haven't solved the C yet. Okay, so before we do that, how do we find the C? Let's do the displacement of Snell. So we're using the antiderivative of velocity from 0 to 15. So this equation is, so this antiderivative is not in the formula. So we're going to use GC. So don't forget to use GC here. Graphics calculator, how do we use it? I'm going to show on the screen on the left. So we're just using the graphics calculator, plugging those 0 to 15, 1.4 times by log bracket 1 plus x squared. So the answer is a 76.431. Okay, so now we put together, because those two has to be, because they eventually catch up. So we call, so the velocity of displacement of the ant, which is on the left, equal to the displacement of the Snell, 76.0431. Now on the left-hand side, we're going to integrate it. So we can integrate it to that, then substitute the value into the equation. So we got that. So the answer, we found a C equal to, so let's have a look at C. So you can see that's eventually C will be equal to negative, graphics again, 1.6523. So therefore, the velocity of the general formula for the velocity of the ant is 2t minus 1.6523. Then we substitute time equal to 12. So don't forget that we want to find the velocity for the ant at point A. Point A means time equal to 12 minutes. So substitute, so the answer will be 22.35 centimeter per minute. That's it, the solution for the question 17. So this involved two-stage antiderivative for the velocity become displacement. And this is a very good question to understand the relationship between velocity and acceleration. I hope you enjoyed the video. If you do, please give us a thumbs up and don't forget subscribe to channel so you don't miss any latest video. Thank you for watching. I'll see you next time. Bye.